Lesson 12.5 is on predictions. So one of the biggest reasons we go through and do scatter plots and find the correlation of coefficient in the least squares regression line is so that if we do have a relationship or a correlation, we can use our least squares regression line to predict y given a value of x. So here's an example. We're going to use the same example that we used in class before, where we took the third exam score and our final exam score. And if you remember, we had a least squares regression line of y hat equals negative 173.51 plus 4.83x. Okay, what we'd like to do is predict the final exam grade of a student who scored 71 on the third exam. You'll notice that I have 3 students that did score 71, and we have their grades right here: 185, 163, and 159. And those are the actual observed scores. We want to figure out what would be the predicted score based on our least squares regression line. So all I need to do is plug in the 71 for my x, because that would be the score on the third exam. Put this into my calculator, and I come up with y hat equals 169.42. Okay, that's what we would predict somebody who scored a 71 on the third exam to get on the final exam based on this least squares regression line. This is called interpolation. It's predicting inside the observed x values, and this is a good prediction when R is strong. Okay, if I have a good strong R, meaning it's 0.6 or above, we're making a pretty good prediction on this one. Okay, so what would be the predicted final exam grade of a student who scored 95 on the third exam? So I use my same least squares regression line, but this time I'm going to put 95 in for x, and I come up with a y hat, or a predicted value of y, of 285.34. Okay, first of all, look at that score compared to the other final exam scores. I'm guessing the final exam was out of 200 because my highest score here is a 185, or no, there is a 198, but I end up with a predicted final exam score of 285.34, which is not reasonable. Okay, but what we did in this particular problem is we used extrapolation, where we predicted outside the observed x values. This is not a good prediction. It doesn't matter how strong the correlation is when you predict outside of the observed x values, meaning 95, which was a much higher score on the third exam than any of the other scores. It looks like my highest score on the third exam, if you look over here, was a 75. So scoring a 95 was probably not possible on that particular exam. You're trying to predict something outside of those values, and you'll see sometimes you'll get a reasonable answer, but it's still not a good prediction. Okay, so data with a correlation coefficient closer to 1 or negative 1 will have more accurate predictions than data with a correlation coefficient closer to 0. Remember, the closer you are to 1 or negative 1, the stronger relationship you have, so you're going to make better predictions. Okay, the closer you are to 0, the weaker that correlation is, the predictions aren't going to be as accurate.